Hello and welcome. This is Matthew, and today, for the 42nd official video on this channel, I figured it's time to become a real YouTuber and do an unboxing video. And it's sort of appropriate that we happen to be on video 42 because, as we all know, 42 is the ultimate answer to the ultimate question of life, the universe, and everything. And what better answer to life, the universe, and everything than a box from IBM? So what do we have here? Let's have the camera fly over and reveal what's inside. It is an IBM System MT 9006. This is a dual POWER9 2U server. Let's see if we can read the parts here. I'll tilt the camera down a little bit for you. Okay, so you can see primary OS Linux. This was actually ordered with Red Hat licenses for all of its CPU cores. Important note, so the server is also called an IBM LC922. So this is one of their servers that only runs Linux. It does not have the IBM firmware support to run the IBM I operating system. And it doesn't have the firmware support to directly boot AIX. It can only boot essentially Linux or theoretically FreeBSD. This is based on the OpenPower reference implementation, and it's running the Petiteboot Linux-based bootloader. So it does kexec-based booting, which is a Linux thing that some other operating systems have added support for. So this is really a compute server for running essentially open source workloads, which is great. I'm gonna put this out of the data center and it'll be a really cool server to have online. I'll probably move a lot of my production workloads over to it. You can see here that we have two-port 10 gigabit Ethernet with SFP plus sockets in them. So the motherboard actually has 4 10 gigabit copper network interfaces on it, but then whoever originally ordered this server ordered it with the 2 extra 2-port SFP based, so they can do fiber 10 gigabit Ethernet. It also has 2 fiber channel adapters. Those are also 2 ports each. These are, I believe, 16 gigabit fiber channel. I don't really have a use for those. I don't run a SAN out of the data center this will live at. And then, of course, here's the important part, the actual system itself, the 9006-22C. It's a dual socket 2U server with 12 3.5-inch hard drive bays. And it has 2 2-terabyte SAS hard drives in it already. It has, these are 4 8-gigabyte DIMMs, so only 32 gigs of RAM as it was configured from the factory, but I have 256 gigs of ECC memory to drop in it, so we'll have plenty of memory. And there they are, 2 POWER9 processors, 16 cores each, 190 watt total power dissipation. They are the design revision 2.2 or 2.21 of the POWER9 processors. These are the Sforza, S-F-O-R-Z-A processors, if you're familiar with the various POWER9 processor lines. And it's kind of rubbed out here, but 2.9 gigahertz. And these are SMT4 processors. So 2 of them, 32 cores, 4 threads per core. This will present as 128 processors to the operating system that you have running on the system. So pretty exciting stuff, very cool. Got a phenomenal deal on this. This is actually manufactured by Supermicro for IBM. So Supermicro makes a POWER9 motherboard based on the OpenPower reference implementation. And Supermicro makes the chassis for this as well. So it's branded IBM, but in reality, it's a Supermicro system. It's essentially what you would get if you bought a Raptor Talos 2 POWER9 system. So if you go to Raptor Computing Systems and you look at their products, I believe, someone can correct me in the comments if I'm wrong, but I'm almost certain Supermicro makes the motherboards for Raptor as well, for those Talos 2 systems. So let me get a different tripod here and we will open this box up. Okay, let's do this. One side. Two sides and the top. There we go. All right, so we have an outer box and an inner box, it looks like. Open up the inner box. And here we are. This is brand new. Never been taken out of the box as far as I can tell. This should be our accessories. Yep, hardware information. So this is just going to be some PDF manuals and other documentation, probably mainly regulatory information. We have 2 power cords. It is dual power supply, of course, redundant power supply. And it looks like some brackets and screws. This may be rack mount adapters for various types of mounting. And those look like hard drive screws. So this is nice. Unlike a lot of sort of real IBM servers, this has the drive trays that aren't just blank fillers. You can actually put hard drives in them. So they're not screwing you and making you have to order their particular hard drives that come in their drive trays. Some cable management stuff. And, okay, so then these are 2 more power cords, but this is typically, let me go closer here to show you. This is typically what you use in data centers that are running 240 volt power. So you have PDUs in your data center racks that will let this plug in. The server itself runs on both 120 and 240. It's not like my Power 8 server that requires 240 volts. Okay, so that's it in the box. Let's see what else. We have the rack mount rails. They're sort of integrated into these styrofoam pieces. We don't need those right now. And the other rack mount rail. And the server. So let's see. Let's put this on the box like that. Yeah, that'll work. And here's the seal. Get this plastic off, and then we'll take a closer look. And here we are. It's still wrapped in plastic. It has the plastic film over everything. So this really is a new server. You can see we have the 12 hard drive slots, and most of these are empty trays. They just have the air baffle blocker in them. But with those screws, you can just install any hard drive you want to. And I'm not sure if we'll be able to see. So these are SAS and SATA slots. Can't quite see the connector. But then I believe the 4 slots over on the right here also support, I think it's the U2 NVMe hard drive connectors. And I can't really see on camera here, but yeah, so I can actually read on the back plane SAS number 11 and then NVMe number 3. So you can have front hot swappable tray loaded NVMe drives in 4 of the slots. And 2 of the slots should have, yep, the hard drives. So 2 terabyte, looks like Seagate Exos 78 SAS hard drives. And in slot 0 down there as well. Cool, let's go around to the back. All right, so well equipped. Starting with the redundant hot swappable power supplies we have here. All right, so here's where you can prominently see the Supermicro branding. I think this is a relatively standard Supermicro chassis. So if you need things like replacement power supplies in the future, it shouldn't be too hard to find. And looks like these will do 1,000 watts at 120 volts or 1,600 watts at 220, 240. They're 80 plus platinum, 80 plus titanium certified. It's not too bad. This looks like a fiber channel card. So let's pull out one of the SFPs here. Okay, so Finisar, Sunnyvale, California, standard stuff, 850 nanometer. So if you had any fiber channel SAN needs, this will cover it. So there's one there, and it looks like another one tucked away up in there. And then that leaves the 2 dual port 10 gigabit Ethernet controllers. No SFPs in there, so you'd provide your own optics. This also has 4 10 gigabit copper ports on the motherboard. So you can do 10 gigabit Ethernet in each of those. And then this is a dedicated Ethernet interface for the onboard management, the IPMI management. So again, unlike the what I sort of call real IBM servers, although this of course says IBM on the box and it says IBM on the front, so it's just as real as anything else. But again, really, this is a Supermicro designed and built server based on OpenPower. So unlike the IBM servers that run ASME, their Advanced System Management Interface, this is a standard IPMI BMC management based system. So you can use IPMI tool from another Linux host to manage this system, turn it on, turn it off, get the virtual serial port, all those kinds of things. So that's the IPMI interface. And then those are the Ethernet interfaces available to the operating system, serial port, and it does actually have VGA video if you just wanted to plug in a VGA console and a USB keyboard. So let's pop this thing open. All right, there are 2 release tabs here, but I'm guessing somewhere along the side, yeah, there's a screw. It looks like just 1 on each side. So 2 very small screws securing the cover in place. Okay, and push the tabs and lift it off. All right, here we are. So general layout, of course we have the hard drive back plane. Looks like 4 fans. These are just, heat, little air shrouds to keep the air nicely going over and through the processor heatsink fins. We can just pull those out. And that's where the magic happens. The 2 POWER9 processors. It has 16 memory slots, but you get the highest memory bandwidth on these POWER9 systems, the 2-socket POWER9 systems, if you populate 8 of the memory slots. Take standard DDR4, what is it, PC2666, ECC registered RAM. It no longer uses those crazy 2U tall IBM buffered DIMMs. So again, open power, reference design, standard components, really nice. Looking around, what else do we have? So this does theoretically support 2 full-length, full-width video cards. So you can drop, an NVIDIA CUDA compute GPU in here, or 2 of them. Might be blocked by the camera. There's a GPU power plug back here. Let me see if I can show you that. Yeah, so that's labeled GPU power 1. And those are labeled GPU power 2 and GPU power 3. So again, if you're dropping those large GPUs in here, there's power right on the motherboard that you can plug into them. So I'm guessing the full-sized cards would go in this PCI slot area because of that, and then these 2 down here would serve if you have a full-size card in, the riser in here. Otherwise, it looks like a computer motherboard. There's an integrated micro semi SAS controller. So all of the drive backplane connections are coming here, and I wonder if that's actually what's under the heatsink there. And you can see SATA ports in there. So that's an option if you have a little SATA flash drive that can actually just plug right in there, maybe as a boot device. And then also an onboard USB port. So you can probably, again, if you just need a minimal operating system to boot this thing, and then the rest of your storage is either on board or through those fiber channel cards, you could just have a little USB flash device that you boot the system from. There's the RAM slots. Pretty nice. All right, I guess the next step is to power it on. Well, we have the system plugged in up here in the lab now. As I mentioned earlier, you should be able to get this fully up and running just using serial over LAN through the IPMI management interface. So if you just racked this in the data center, plugged it into the network in that IPMI management port, I believe the default should be that it will grab a DHCP address. So you can just look in your DHCP server to see what address it got. You can initiate a serial over LAN connection from your IPMI tool on another Linux system. And then you can also use IPMI tool to power the machine up. But since it has the serial port, since it has the VGA port, and because it has a USB port for a keyboard, I figured we'll just take the easy way here and plug in a monitor and a keyboard and see what happens. So let's push the power button. There it is, open power. I imagine it starts out, so some of the fans have already slowed down a bit. That sounded like power supply fans that went all the way up. I think we need to hit a, so welcome to host boot. It's running through some steps here. It does have a TPM in it if you want to use it. So it has an I2C accessible TPM if you wanted to set up a secure boot chain, I imagine is what that would be for. Yeah, it sounded like the power supply fans went full and then have already died down. Now you're just hearing those 4 chassis fans, which after everything starts up and self-tests, will probably die down quite a bit. Okay, so I see HWAS functional listing the DIMMs. So it looked like that sort of long wait there was probably doing an initial memory test. All sorts of messages going by. I'm not sure if you can actually install
say, the Raptor open power, fully open source firmware. If you were to compile that, build it, if you'd be able to install it on this, or if this does actually check the firmware signature and it has to be a Supermicro signed firmware. Maybe something to experiment with. That being, of course, the big deal about the Raptor Talos box is that the whole stack, top to bottom, hardware all the way up to the firmware, and then, of course, Linux operating system that you're running on it is open source. Okay, so I see fiber channel cards, I see onboard BNC, onboard LAN, so it's going through all of the hardware. Okay, here we go. So this is the Petiteboot loader. Let me see if I can move this closer here. Oh, there we go. So now all the fans, so this is more the idle level. It's kind of finding the idle level. Good. So 9006-22P, that's the machine model. Sorry, my finger's getting in front of the camera there, but let me straighten that out. Okay, so we have system information, system configuration, status log, language, rescan devices, retrieve config from URL. This, of course, can boot from any kexec loadable kernel over HTTP, HTTPS, FTP. So it's network bootable that way. I don't know if it does traditional PXE booting at all. I don't think so. That's just an x86 thing, right? But this bootloader is able to boot from a variety of network protocols. 0 plugins, exit to shell. Let's look at system information. All right, so primary platform versions, Open Power, Supermicro, P9, DSU. Again, I don't think you can buy that motherboard from Supermicro, but that's the motherboard model number, P9 DSU. OP build, ski boot, host boot, OCC, Linux. So again, this Petiteboot is actually based on Linux. So I believe this is running a Linux 4.16.7 Open Power 2 kernel right here to support the bootloader. So that's all cool. Then BMC, baseboard management controller, management interface, MAC address, and the Ethernet interfaces. So again, there's 4 onboard gigabit, 10 gigabit copper interfaces, and then it had those 2 dual port 10 gigabit cards as well. What can you do in system configuration? Auto boot disabled, enabled. So auto boot will be once an operating system is installed, does it go ahead and boot it automatically? Boot order, typical stuff here, network device, add device, timeout. Network, it'll auto DHCP all active interfaces from right here in the bootloader. DNS servers, okay. Disk read write, oh, that's interesting. You can actually have the firmware prevent writing to disk, or your bootloader can write to disks. And then boot console. Okay, yeah, so the console itself, what we're looking at here, is accessible and can be directed to IPMI serial port, or just VGA. I guess the VGA port is still showing the IPMI serial console. Oh, actually, yeah, so current interface TTY 0. Okay, so yeah, so TTY 0 is tied to the IPMI, I'm guessing, and then TTY 1 might be the serial port on the back of the box. Could be the other way around. Have to play around with that, but either way, that looks good. Status log. And yeah, you can see one of the interfaces grabbed an IP address from DHCP, and it looks like, oh, actually, yeah, it looks like TFTP, it is looking for a PXE config. So I'm guessing over the wire, it's not actually PXE, but probably can use similar configuration and setup as PXE booting would. Actually, yeah, PXE auto configuration failed. So maybe it is just, maybe it also supports regular old PXE. X to exit. Oh, I think I hit escape and exit. You can see down here, we're now actually in the Petiteboot shell. So this is Linux, right? So the bootloader, the firmware of this thing, actually just runs Linux, which again is part of that whole Open Power initiative. And again, I'm not sure about installing non-Supermicro signed firmware in this thing, but fundamentally, this is mostly running the same OpenPOWER firmware stack that, say, the Raptor Talos 2 would be running. All right, well, that, I think, is going to be it for this video. This is just an unboxing, not an installation video, but you can see there we have the IBM LC922 dual socket POWER9 server. So I'm excited to get this thing up and running. Let me know in the comments below if you had 2 sockets of 16 cores apiece with SMT4 hardware symmetrical multi-threading running Linux, what kind of compute jobs would you run on it? What do you want to see on this thing? In any case, thanks for watching, and I'll see you next time.